Welcome to Unit 5, Lesson 10, Interpreting and Writing Logarithmic Equations. Let's look at logarithms with different bases. Okay, now remember, I told you last lesson, when you have log base 10 and it starts with a 1, all you got to do is count the number of zeros. So, for the first one, is 8 zeros in there, that's why it's equal to 8. For the second one is no zeros, that's why 0. So now let's look at changing it to exponential form. 10 to the 8th power is a 1 with 8 zeros behind it. 5, 6, 7, 8. Okay, 100 million. Okay, 10 to the 0 equals 1. Now, let's look at something different here. 2 to the 4th power equals 16. 2 times 2 is 4, times 2 is 8, times 2 more is 16. That's four fingers I'm holding up. So if you do that in your hand, if you hold up 2, 1 is 2, 2 fingers is 4, because multiply by 2. Multiply by 2 again when you put up your third finger, that gets you to 8. Multiply by 2 when you hold up your fourth finger, that gets you to 16. You can do the 2s on your fingers. Okay, and for the last one, 5 squared is 25. And we know that 5 times 5 is 25. So we have different bases, and I'm going to show you how to do this on the calculator. Okay, again, back in my day when I was learning math, we had to read logarithm charts. You don't have to do that anymore because you have calculators. So we're going to use the chart to answer the first one, but after this, we're not going to use the chart anymore. I'm going to show you how to do it on the calculator for the first question. So log base 2 of 2, look in the chart, is equal to 1. And then find 32 on the chart. 32 is right there. That's equal to 5. 15 is not a whole number. It's not a exponent of 4. So we get 3.9069. And then 40 is not an exact multiple. And that gives us 5.3219. So now, our log, we're in exponential form, and we got to rewrite these in a logarithmic form. So log, the base is 2, so 2 is our subscript. The answer is 5, that goes next to the, and then the exponent goes on the other side. And so now, to type this into the calculator, and they didn't tell us now, you want to hit the math button. It's under the green button. Arrow down until you see A, log base. So you're going to use the arrow, which is those circular buttons. Scroll down, or the buttons, the direction the arrow is off to the right, until you get to A. It's going to be 0, 1, 2, 3, 4. Oh, no, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Then it goes A, B, C, D, E, F, G. And now, when you hit enter, you're going to see log. You're going to see a square here and a square here. Put the 2 and the 5 in the boxes. Hit 2, right arrow over. Put the 5 in, hit enter, and you will get your number. So the next one is log base 2 of 70 equals what? And then the next one is log base 2 of 999 equals, and let's punch these into the calculator. Okay, now remember, we're rounding the 4 digits after the decimal because sometimes the Delta Math will ask us to do that. So for log base 2 of 5, we get 2.32192. So that gives us 2.3219. After the 9 is a 2, so the 9 stays 9. So for log base 2 of 70, we get 6.21928. The 8 is higher than 5, so it pushes the 2 to a 3. And for log base 2 of 999, we get 9.9643. The 4 makes the 3 stays the same. It does not do it. Remember, 0 to 4, the number you're rounding to stays the same. 5 or higher, the number to the right of the place value you're rounding to pushes the number you're rounding to up. You have to remember that because it's going to be important for the delta math. Okay, now, on the left here, this is logarithmic form. And on the right, it's the same expression written in different forms. That's called exponential. So let's write this down. This is logarithmic. And this is exponential. And so what they want us to do in this table here is rewrite exponential form to logarithmic or logarithmic to exponential. So let's do it. Log base 2 of 2 equals 1. The only thing that switches is the exponent and the answer, or the answer and the exponent and the answer. That's the only thing that switches. So log, and for log base 10, we just write log because that's all that's on the calculator. When it's log base 10, you do not have to write the base 10. Log base 10 of 1 equals 0. So remember, to go from logarithmic, the answer and the exponent switch. The base is 3 to the 4th power equals 81. 5 to the 0 power equals 1. To go from exponential to logarithmic, the switch. So log of 1/10 equals -1. And we know that 10 to the -1 equals 1 over 10. Remember, negative exponents flip a fraction upside down. So log base 9, because it's not base 10, of 3 equals 1/2. Because 9 to the 1/2 power is 3. Or the square root of 9 is 3. Now, our base is 2. Our answer is -3, and that's 1 over 8. Because 2 to the -3 equals 1 over 2 cubed, and 2 cubed is 8. All right, 2 to the y equals 15. We get log base 2. We had to write the 2 because it's not 10, of 15 equals y. And then 5 to the y equals 40. And then log base b of x equals, what's that, y? Y. Okay. Write two equations, one in exponential, one logarithmic, to represent each question. Use question mark for the unknown value. To what exponent? Exponent. Do we raise the number 4 to get 64? 4 to what exponent? Question mark equals 64. Changing it, log base 4 of 64 equals what? What is the log base 2 of 128? So let's write log form first. Log base 2 of 128 equals what? 2 to what power equals 128?